So you have another example here involving the beetle walking in that same circle. You can kind of read the description there, but now it's asking what was the beetle's speed, assuming that it did not speed up or slow down as it completed the circle. So finally, I think we're ready to do a calculation here because speed is distance over time, and distance in this case would correspond to the path length difference, which is really going to be the circumference of this circle. So I could probably start by looking at distance and use the formula 2 pi r to calculate that for this circle. So that's going to be 2 times pi times 5 centimeters. I'll put 5.00 centimeters just for fun. And I'm going to go to my calculator here and see that that is like 31.4. There's more here. I'll probably, I mean, everything's presented to us at 3 sig figs. So maybe one thing worth addressing here is it's actually like 31.415. It's kind of the expansion of pi, but it looks like, but multiplied by 10. I guess that kind of makes sense, right? So I'm going to keep a couple extra here because that's a general rule that I follow. If I know that my final answer is going to be at a certain number of significant figures, which in this case from these numbers it looks like is going to be 3. So I'm keeping 5 here. That's 2 more than I'm going to need because I've got distance, but I want to divide by time. So, right, because speed is distance divided by time. So for distance, I can just put in the 31.416 centimeters I just calculated. And for time, I'm given 20 seconds. So I'm going to put that in, take those numbers and put them into my calculator. And, you know, if you want to on your calculator, if you have still this number, I think I did that here actually. I just put it with unrounded. But even if you did round off, at 3 significant figures, I'm getting 1.57. And that's probably going to be safe provided, like if I'd rounded this off to 32, you could try that. And you'll see that you won't get things correct here. And pardon me, I made a mark there. And so the final units, though, I mean, like if I just left this way, this also wouldn't be good. If you do this on an exam, I'm probably going to make some mark because you want to track those units all the way through in physics class. That's super important. Most science classes have that characteristic. And again, if somebody like in my class, if somebody said instead of 1.57, maybe if they put the next digit there, which might be a 1, and then maybe after that would be like an 0.8 actually, if you round it off, if it didn't round off further, that is, I'd actually be okay with that. It does say this is the constant magnitude of the instantaneous velocity throughout the beetle's journey, but it is also simply distance divided by time. And that's just kind of tying into the concept that if you ask, like, so how big were these arrows that we were drawing for velocity vectors earlier, we actually calculated that right here.